Hi folks, today I have a lesson for you on stoichiometry and how it relates to thermochemical equations. Thermochemistry is usually a concept that is discussed and taught in grade 11. And thermochemistry is, or thermochemical equations or energy is just introduced. Now we are going to further dive into thermochemical equations. Over here I have for you is an example of two equations. I have CaO, calcium oxide, plus carbon, which requires 462.3 kilojoules of energy per mole, and forms calcium carbide and carbon monoxide. If you observe this equation carefully, we see that the energy is written on the left-hand side of the equation, right here, which means in this reaction, the energy is being absorbed. It is part of the reactant. All right. So in this case, we have energy on the left, and therefore energy is required for this reaction to progress. On the second equation, I have the same equation. I have flipped it around, and in this case, you see energy is on the right-hand side. What this means is, in this reaction, energy is released. I'll give you analogies. For the first one, where energy is on the left-hand side. An example would be like cooking food. When you're cooking food, the food needs the energy to transform into that edible food that we like to eat. For that to happen, the food requires energy. Another example, if you have bread, it will need heat to turn into a toast. That is also absorbing energy. Reactions which absorb energy to transform into products are called endothermic reactions. Endothermic. Endo means taking in. Thermic is heat. They are taking in heat to become products, and therefore endothermic reaction. If we wanted to write this equation with energy as a separate component, the equation would be written as CaO plus 3C forming CaC2 plus CO with a delta H. Delta H is the energy of the system, and in this case, because the energy is being absorbed, it is going to be positive 462.3 kilojoules. Right. So this is going to be 462.3 kilojoules per mole of calcium oxide, or per 3 moles of carbon, or per mole of calcium carbide, or per mole of carbon monoxide. And that has to do with the coefficients in the equation. So this is the delta H for the equation, in other words. Let's look at the second equation that we have on the right-hand side. We have calcium carbide plus carbon monoxide forming calcium oxide and 3 carbons. Energy is on the right-hand side. If we were to rewrite this equation with energy as a separate component with a delta H value, it would look like this. CaC2 plus CO forming calcium oxide plus 3 carbons, and the delta H in this case is going to be negative 462.3 kilojoules. The reason for being negative is because the system, which is the calcium carbide and carbon monoxide, is losing energy. Now energy is separate from the product, and therefore the delta H value, the energy of the system, has been reduced. So that is how to write the equations with energy separately and how to write the equation with energy as part of the equation, which is these are called thermochemical equations because they have energy as a component of the chemical equation. Now, the first question we have here for you is, what is enthalpy change of a reaction? Enthalpy change, the delta H that we have just written above, is considered enthalpy change. Enthalpy is the energy of the system. it is very hard or difficult to determine how much energy a system really possesses. But when a chemical reaction takes place, it is much easier to determine what is the change in energy of the system, which is considered the enthalpy change. So enthalpy change is the change in energy of the system, right? So it is easier to tell the change rather than knowing the overall energy of the system. And the easy example is, let's say you are walking to school, okay? And you lose $5. Now, it is hard to tell what was your net worth before, and it is hard to tell what your net worth is afterwards. For that, we will have to go into the bank balances and policies and other things. But to determine the change in energy or change in net worth, since you lost $5, your net worth has gone down by $5. So your change in net value, and delta H if you want, is negative $5. In the same way, if you won the lottery and you, or the raffle, and you got $2,000, it is much easier to calculate your change in net value rather than figuring out your net value. So your net worth would have gone up by 2,000 because you just won a raffle for $2,000, and therefore the delta H would be plus 2,000 if it was for a person, and you're looking at money. In this case, we are looking at energy. In the same way, when it is easier to tell the change in energy of the system rather than finding the absolute energy of a system. Right, and so that is enthalpy change. So enthalpy change is essentially the change in energy of the system. If the system absorbs energy, so endothermic, the system absorbs energy, the delta H is going to be positive. And if the system releases energy, and we can write it here, it is called exothermic reaction. Exothermic reaction, which means the energy was lost, and then therefore the energy of the system would be reduced and would be a negative value. Now let's try to use this information, and what we are going to be doing is we're going to be focusing on the first equation to figure out the next two questions that we have below. And the answers with using either equation would be the same, but we will just focus on the first equation. So let me just clean this up for us. And we are going to now focus on the first equation here. Okay. All right. So let us just rewrite the equation so that we are clear that we are working with this equation. Calcium oxide plus 3 carbons plus 462.3 kilojoules of energy forms calcium carbide plus carbon monoxide. Our equation is balanced, and what we're going to be looking for now is the mass of calcium carbide that would be produced using 246.7 kilojoules of energy. Right away, we can see that we will be able to produce less than a mole, because to produce 1 mole of calcium carbide, we need 462.3 kilojoules of energy, and we don't have as much. So we will be making less than 1 mole of calcium carbide. But we are looking for the mass, and let's actually work through the problem and figure out what is the mass of calcium carbide that is produced. So I will write my statement: mass of calcium carbide is equal to the amount of energy that is given to us. We have 246.7 kilojoules of energy that is provided, times, using the balanced chemical equation, we can use them as conversion factors, right? And you did conversion factors in grade 9 and grade 10, how to use conversion factors to convert one piece of information into another, and we're going to use the same skill here. We have to convert information about energy into calcium carbide. So what we're going to do is we are going to focus on two areas of this equation, the amount of energy and the calcium carbide, the coefficient in front of it. So the conversion factor, the amount of energy, we want to cross out the energy, so it will be at the bottom, 462.3 kilojoules, and we want to convert the information into information about calcium carbide, and therefore calcium carbide will be on top, 1 mole of calcium carbide. So 1 mole of calcium carbide is produced when we consume 462.3 kilojoules of energy, so this is our conversion factor. When we solve this, we will be able to cross out the kilojoules and the kilojoules. The answer will be in terms of calcium carbide, but it will be the moles. We want to convert it into mass. So we have to multiply it. Moles times molar mass is mass, right? This is from grade 11. So we need to find the molar mass of calcium carbide. So just calculating the molar mass of calcium carbide, and the carbon is 40.08 plus carbon is 12.01 times 2. So calcium was 40.08, carbon is 12.01, but we have two carbons, so times 2, which gives us a total of 64.10 grams per 1 mole of CaC2. Now we have enough information to convert our energy into mass. Now let's just put this information into the calculator. So 246.7 times 1 divided by 462.3 multiplied by 64.10, and we get an answer of 34.2060783. But looking at significant figures, our question had 4, so our answer should have only 4 significant figures. So it would be 34.21 grams of CaC2. So amount of calcium carbide that is going to be produced in this reaction is going to be 34.21 grams. All right. So this is how we can relate our energy into our reactants and products as well. So it is going to consume, if you're writing a statement, the system is going to consume 246.7 kilojoules of energy, or it's going to absorb 246.7 kilojoules of energy to produce 34.21 grams of calcium carbide, assuming, obviously, that the calcium oxide and carbon is in excess, sufficient amounts to perform the reaction. I have another example here at the bottom for you, which is calculating the mass of carbon monoxide. So when we have 743 kilojoules of energy, so this question is going to be done almost the same way as the question we just did, and I'm going to again rewrite the equation for us at the bottom here. Calcium oxide plus 3 carbons plus 462.3 kilojoules of energy forms calcium carbide plus carbon monoxide. And in this scenario, we have the amount of energy given to us as 743 kilojoules of energy. So, and we are looking for mass of CO. So I'm just going to write a statement again. Mass of CO is equal to, we're going to take 743 kilojoules of energy that we are provided, multiply it by the conversion factor, conversion between carbon monoxide and the energy. So the relationship is 1 CO. To produce 1 carbon monoxide, 1 mole of carbon monoxide, it takes 462.3 kilojoules of energy. So this is going to be a conversion factor, and I can actually write the word mole for us just to avoid any confusion. Okay, there we go. So by performing this calculation, the kilojoules, if you see the units of kilojoules, they will cancel out. But we are looking for the mass. So to find the mass, we have to also take the moles and multiply by the molar mass. Molar mass of carbon monoxide is 12.01, which is one carbon's molar mass, plus 16.00, which is equal to 28.01. 28.01 grams in every mole of CO. Now, moles of CO and moles of CO will cancel out. There we go. That was the whole idea. Energy will cancel out, and our final answer will be in grams, and that is what we are looking for. So now we can go ahead and use our calculator to plug all the values in. So 743 divided by 462.3 times 28.01, and that gives us an answer of 45.01715336. Looking at the question, we have three significant figures. 7, 4, and 3 is three significant figures. So the answer will be only worth three significant figures, 45.0 grams. So in other words, if we have 743 kilojoules of energy, we would be able to produce 45.0 grams of carbon monoxide.